By the way, I just minted my first Mocha ID yesterday. All right. So next coming up, let's welcome Dr. Zhou from EthStorage to give us a keynote speech. Welcome, Dr. Zhou.
So, hello everyone. So today I'm going to talk about mainly the roadmap of Ethereum, especially in terms of its scalability roadmap and how we are able to play an important role to better secure the Ethereum future ecosystem. So the topic is about enhancing robot security with long-term DA and also ZK fraud proof. So before I start, let me first self-introduce myself. I have been working in the blockchain space since 2018. Before that, I was a software engineer at, at Facebook, Google, and I have been working on Ethereum ecosystems with a couple of the suite of EIPs, including like EIP 4804, and also get a PhD from Georgia Tech. So my primary focusing on Ethereum data availability and also layer 2 technologies, and received a couple of grants from, for example, Vitalik himself, and also data availability research, sampling research, and also EthStorage itself. So why we want to do EthStorage? Why we want to do this? First, we would like to understand what the future needs on top of Ethereum. So Ethereum is now working towards called Rollup-centric roadmap, which the basic idea is to scale Ethereum while using Ethereum security. And the basic idea is to do off-chain execution while we want to secure those off-chain execution with all kinds of technologies. The one key technologies is we call on-chain verification of off-chain execution. This is turns to two types of rollups. One is called optimistic rollup, and another is called ZK rollup. So that now we are able to verify the execution of layer 2 in the layer 1 with much cost-efficient way. The second thing is that we want to make sure all the data that is executed on top of layer 2 can be retrieved by everybody. So no one is able to withhold the data. And this is basically the idea of data availability. And right now, Ethereum EIP 4844 is implementing this feature, and it will be the core feature of Ethereum that in the next Ethereum Cancun upgrade. So this diagram shows the importance of these two features, this diagram is also posted by Vitalik's blog. So with all these updates, we solve all the problems of Ethereum. So if we take a closer look of how those are implemented, we're still facing a couple of critical issues. First of all, data availability technologies like EIP4844 and DAG sharding will discard the data in a few days, roughly about 2 weeks, which breaks a lot of assumptions of existing rollups and may hurt the security assumption of all these rollups. And second, all those on-chain verification technique based on fraud proof, availability proof can be super expensive and also buggy. And it is not yet battle tested. And any issue that created by them may cause hundreds of millions or even billions of loss. And also, if you dive in more details, a couple of implementations like on-chain dispute game or fraud proof can also take a very long time to settle, and also gas fee to interact. And ZKP is still very expensive to prove every transactions, and also hard to upgrade with new EIPs. So let's go into details. So this is the spec that is uploaded in the Ethereum repo to describe how they modify the minimum data that is retained in the EIP 4844, which basically reduces the time to 18 days by default. The reason is that they want to minimize the storage burden of the node operators. So, and this is the issue when we have a large amount of data that can be uploaded into Ethereum. But the point is, where can we store the data? And in addition, there's a famous EIP that's called EIP 4444, which will even discard the Ethereum blocks, all the Ethereum core data transactions older than 1 year. So there's an excellent panel that was held on Monday with a couple of the core developers. They are discussing what happened after EIP 444 will result in like other issues like security assumptions and why EIP 444 is needed. So why we want to, what's the problem of discarding this data first? This will significantly break the current security assumption that Rollup is able to recover the latest state from the genesis of layer 2 from layer 1. So anyone is able to recover the latest state so that they can perform fraud proof or even like forcible withdrawal, like exit hatch in the layer 2. However, by discarding this data, then it is impossible for anyone to be able to recover this state, which means that attacking these rollers by, for example, by fraud proof will be much, much harder. So why Ethereum say, hey, we want to discard this data? The core issue is that there's no any in-protocol incentive for storing historical data, which can be block data or DA data. And also, pruning this data has no any penalty. So unlike a state that running in the Ethereum virtual machine, the node has to maintain the latest state so that they're able to validate the new block by replaying all the transactions with the state data. However, once the block is validated and finalized, essentially everyone can discard the data on their nodes. So there's a famous, I would say, debates on Twitter that is triggered by the core developer of Ethereum, Core Peter. He is the maintainer of Go Ethereum, the largest Ethereum node that is run by current the operators. Like right now, it consists of 80% of the nodes. He is complaining that other nodes, other implementations, try to discard this data so that they can marketing their nodes with less storage requirements, which breaks the current Ethereum protocol, but without any penalty. And he further complained that if this kind of thing happens again, then he will potentially leave Ethereum and just take a bag of popcorn and see what happens. And which I think this is really, really bad for the future of Ethereum. So this motivates us to see, hey, how we are able to solve this problem using smart contract and build a modular layer so that even there's no in-protocol support of storing this historical data, but we can using smart contract to able to extend the availability time of these blocks in a fully decentralized way. So we don't want to impose any in-protocol upgrades because that will take a lot of time to experiment, to test. We just want to deploy a smart contract. And the users, since we need to be able to build this incentivization mechanism, so we still need to ask the users to pay a little bit extra storage fee so that the data can be extended or potentially permanently. And lastly, to become a storage provider is permissionless. Everybody, even a laptop, can become a storage providers and prove that, oh, I really store the historical data of Ethereum and collect corresponding reward from the users. And this can be the hint of how the future of the Ethereum in-protocol storage network, once the data grows to significantly larger, for example, when dank sharding is ready. So the goal now becomes we can build a modular storage layer on top of Ethereum with proof of storage algorithms inspired by existing storage systems like Filecoin, RV. They have their independent storage systems, they solve their storage problem. But at the same time, Ethereum is going to have large amount of data to support its scalability roadmap. It's possible that we are able to borrow these ideas, build a smart contract out of that, and then using a lot of new technologies like ZK Snark to solve this problem. So the key idea is to store a small amount of data on chain, but we are able to prove that this data is really a large amount of data that is really stored off chain, and sometimes we call it story rollup. So with all these ideas and also technologies, then we are able to scale the storage capacity of Ethereum from terabytes to petabytes, which can satisfy the future storage requirement of Ethereum in about 1 or 2 decades. And another thing is like we can significantly reduce Ethereum storage cost to 1 to the 1,000 or even to 1 to the 10,000. So here is a calculator on our website, so everybody can play it, plug in the number you want, and this also will tell us how we come up with these numbers with some parameters that we have set. And besides all this, the EthStorage can offer much richer features that right now storage system cannot support. Especially, we are able to use Ethereum wallets, with like MetaMask, is able to interact with Ethereum and also EthStorage to store a large amount of data without installing any third-party services, like just Ether, MetaMask wallets. You can store whatever data you want on top of Ethereum. A couple of features like programming large key value store, which allows programming storage, large storage. We also develop Web3 access protocol. You can imagine it's kind of like a decentralized HTTP. And also we have registered this Web3 URL on IANA, that is Internet Management Service. So what is the current progress? Right now, we are integrating with EIP 4844. We have an internal DevNet that is hooking up with the Ethereum next DevNet that's called Dankun. And so with all these ideas working, and also we have developed a couple of tools to support EIP 4844, both in terms of new transaction type and also stress test tools. So right now we are performing stress tests on Ethereum DevNet together with our storage contract deployed on top of Ethereum DevNet. I believe we potentially crashed their DevNet 10 because we send in too much data, so that all our nodes just crashes, which implies all other nodes in the network may also crash. But finally, with the latest DevNet 11, after sending 6 days of transactions, it's still running well. And so I also report this to the Ethereum R&D group. Looks like people are really happy about it. So we hope that with all these efforts we have put into with Ethereum EIP 4844, the full network will be ready, like testnet, early next year. And the mainnet will be also be ready shortly, which we can also deploy and test all these features on top of that. So besides helping to permanent storage for rollups and increase their security, there are a lot of other applications that can enable by EthStorage. For example, if you type EthStorage.io, the website itself is hosted on top of EthStorage. So we are able to host the website by ourselves. We are able to serve for decentralized social network, decompose of NFT with all this data that is on chain and be able to modify by the smart contract. And also we are able to easily migrate a lot of Web2 applications to Web3. Once we solved both the scalability problem of computation, more TPS, and also space. So that's pretty much what we have for EthStorage, and we will soon have a public testnet. So if you are really interested in playing with all these latest technologies, let me know, and we will also send you the free devices, storage devices, so that now you can run the network in your, for example, in your commodity computer or home computer. So just contact us, and we will. Right now we have the first round, and we are expanding to more rounds, and with all these hardware devices that is sending to the testers. So another big direction that now we are also working on is called ZK fraud proof. So like fraud proof is the key technology to ensure the off-chain execution is correct. It's why called interactive dispute game. The basic idea is both the challenger and sequencer, they will play a game so that they are able to do some kind of like binary search on the specific instructions that sequencer and the challenger disagree on, and then they replay this instruction on chain so that they can decide who is honest or not. However, this procedure in general require multiple interactions on chain and also long settlement time. For example, that's why optimistic rollup generally requires 7 days to settle the layer 2 transactions to make sure there are sufficient time for these multiple interactions. So a simple idea is that now we have a breakthrough of the ZK technologies, both in terms of algorithms, theories, and hardware. Then suppose in the future, could it be possible to prove all the layer 2 execution using a low-level languages, and when the program itself is written in high-level programming languages like Go, Ethereum. The good thing is that it can significantly reduce the latency, which means that we can just send a single transaction and we can prove that whether the sequencer or challenger is doing something bad. And also, in contrast to the ZK rollup, since this transaction is only submitted when the sequencer is doing something wrong, that means that we do not need to prove all this correct layer 2 execution that posted by the sequencer, and which greatly save the store proving cost. So in general, we want to harvest both the benefits of the ZK rollup, which is fast finality, and at the same time, we want to dramatically reduce the proof cost of a ZK rollup. And so then how ZK fraud proof works. The basic idea is to validate a general blockchain in a resource-constrained environment. And this resource-constrained environment, in this case, is a layer 1 blockchain, like Ethereum in the EVM. But it can potentially apply to other devices. And this general blockchain, unlike ZK rollup, in general need customized circuits like ZK EVM. They have very, very specific implementation for the corresponding EVM or data structure. This general blockchain can be written by any high-level languages. And then we want to using a very cool technology called ZK virtual machine that is able to prove these high-level languages that is compiled into a low-level language and prove it's correct using ZKVM. So ZKVM basically is trying to verify execution result of the program compiled in the ISA which have Watson. The ISA is low-level instructions, where Watson reads MIPS. And also we have a couple compilers that is able to compile high-level languages into low-level languages. Famous one like Java, Rust, Golang. And we also use Watson as the ISA, especially Watson is, people are saying that it's the uh, internet ISA that's supported by most of browsers and also a lot of developers like front-end developers. And the ZK Watson, we are also collaborate with is definitely the ZK Watson, which is able to support almost all the Watson code, OP code, except some like floating point, all those OP code that are extremely rare to use in the blockchain. So with all this, now we have another question is, what kind of language, high-level language that we want to, and also the corresponding code that we want to compile into Watson and prove it. And since we are working on ZK fraud proof, and then we are looking for a well-adopted ZK layer 2 execution client. And the most popular execution client is the Go Ethereum, or sometimes we call gas. Right now, 80% of the Ethereum nodes running on layer 1 are using gas. And for layer 2, I guess that is 100%. Why? Because it is battle tested, it is well maintained, and this kind of material effects, so that every time there's Ethereum upgrade, people will adopt Go Ethereum, make sure that if there's some issue, they can quickly report it and fix it, maintain it. So be able to verify gas, no matter on layer 1, layer 2, become our problem, or purpose, our key, the goal, so that we want to validate execution of layer 2 gas, or maybe layer 1 gas. But in the ZK proper case, it's layer 2 gas in the ZK Watson environment. But thing is like, the idea is pretty sexy, but there are a lot of problems to bridge the idea to the reality. Especially if you try to using Golang from Google to compile Go Ethereum in Watson and prove it, there are a lot of problems, especially Golang from Google is not designed for ZK. So there are a lot of things that we need to fix. I won't go to the details, but just want to tell you this is a list of issues. And one issue I would like to highlight is that, for example, this is the program, Watson, that compiled by the Google's Golang, which has more than 10, they call it host function or external calls, in order to be able to work with, like, for example, their host environment, for example, open file, close a file, read a file, and which is not able to be supported in the ZK environment. So in the ZK, we only care public input, private inputs, and how to verify this public and private inputs in the circuits. So one of our major goals is to modify the official Go compiler so that now it can compile most of the Go code into a ZK-friendly, approvable Watson with only a few external functions that support public input, public-private input, or something is wrong. And this simplified our model will be very, very friendly for the ZK prover and verifier without any further modification. And that's the goal, that's the motivation of ZK Go. And at the same time, it supports most Go features like GC and Go routine. So I will skip this part. I just want to give a simple tutorial of Fibonacci. So on the left-hand side is a Go lam written, say, hey, I want to scan two initial variable of Fibonacci sequence, and then I want to output the corresponding calculation result after 1,000 Fibonacci sequence calculation. And definitely these two will be impossible to run in top of the in the ZK environment because it relies on additional I/O assumptions. So if we want to prove it in the ZK environment, we have to replace these I/Os with called Watson inputs, which basically asks ZK Watson to provide corresponding public input or private input and then verify if they are correct. And so with ZK Go, for the developers, it's just very simple. As long as the I/O is being used using the Watson one, then it just types ZK Go with the rest of the semantics just exactly the same as Go, and then it just automatically compile the corresponding code that can be proved in the ZK Watson environment. I think I probably will start this first. So we apply these technologies, ZK Go, on top of OP program. That is the optimistic layer 2 gas. And we also open source our code. So right now, with this compilation, we are able to pass all the check, like constraint check and also trace generation, which means that now we are able to prove the whole execution of layer 2 in the ZK Watson environment. And this brings a lot of benefits and also unique features. So one feature is regarding the cost of proving. So right now, the 1 million steps cost is about 1 cent using ZK Watson. And for the ZK fraud proof, that will take about 50 billion, 100 billion instructions, which I believe is perhaps the largest proving system in the world. But even with this large amount of steps, we are able to perform all the ZK fraud proof with about 1,000 US dollar. This is still super expensive for ZK rollups, like for one block transaction proving this. But since ZK fraud proof only happens when something is wrong, so as long as the reward of the challenge is greater than 1,000, which is highly possible, especially the sequencer will have this kind of security policy, then now the ZK fraud proof will work. And this is something we will quickly build out this end-to-end ZK fraud proof in a couple of months. And also, it will be very easy to upgrade because we compile this high-level language implemented in Go into low-level Watson. So any features that are introduced by EIPs, the developer doesn't care how it's being implemented in ZK. It just uses Go to implement all these new EIPs, and they can just almost instantly support it by ZK4 proof technologies. Rather than writing a new circuits, new algorithms in ZK to support that. That's called ZK EVM scary. That's scary that once there are protocol upgrades, they have to adopt new features, they need to re-implement all these things, circuits, and do the audits, which is really, really risky. And also, we are able to contribute to multi-proving system. So there are a couple of future work that we have to be done. First, we make sure everything is end-to-end. So there are a lot of optimization in parallel proving, also aggregation, customized circuits, and a lot of proving system. I think this is pretty much all I have. So thanks everybody for attending. Probably I have 1 minute or 2 minutes. So happy to answer any questions. Sure. Yes. 那 OK。
那它怎么影响非开发人员？比如我是做产品开发的，做产品
Mhm. Oh, so how this will impact the non-developers, but still working in like Web3 space? I think um, so. I don't want to go to technical details, but yeah, in general, that may open a lot of other spaces in this area. For example, we are now also be able to write a gaming on top of the blockchain, and on top or using customized like logic in Go, and then be able to prove it directly. So we want to hide all these details. Like when you're using these like technologies, you just need to understand how to write the corresponding code in like high-level languages. Also for EthStorage case, in, for the users, it doesn't need to understand underlying details. Just I'll call our smart contracts. Hey, I want to write this data and pay the corresponding fee. Everything is done. So I think from as long as the user developers has a little bit understanding of how the blockchain works, smart contract works, and it will automatically like handle the rest of things for them. Yeah. Other questions? Testnet waiting list. You can ping me on my tweets. Just DM me. You cannot. Why? Because I guess. Oh, yeah, because I was being attacked by like, a civil attack. Yeah. Also, shoot me an email. So we will quickly come up with like a survey to ask everybody background and prepare for the next round. Um, DevNet and also public testnet. Yeah. Okay. Thanks, everybody. So if you have questions, feel free to reach out to me. Thanks, everybody. Yeah.
Thank you, Dr. Zhou, for this wonderful, wonderful sharing.